Hello, math students. Now that we've talked about angles that we get with parallel lines and transversals, and we've talked about triangles, now we're going to extend that to other polygons. So a polygon is just a closed figure with all straight or flat edges, no curves on these. And today we're going to be focusing just on the part that's highlighted, just the sum of the interior angles in a polygon. So I have different polygons here, and I would like you to be familiar with these names. Most of them I think that you're already going to know. 3 sides is a triangle. 4 sides, just in general, anything with 4 sides is a quadrilateral. Quad is the prefix for 4. It doesn't have to be a square, right? This one looks like a square because this is a regular polygon, which means that all the sides match. So this would be a square is a type of a quadrilateral, but any 4-sided shape is a quadrilateral. 5 sides is a pentagon. Think about the big government building. It's pentagon. It's 5-sided. Hexagon has the letter X in it, just like 6 has a letter X in it. That'll help you to remember that a hexagon has 6 sides. A heptagon has 7 sides. Some people want to say septagon, and that's not the right word. It's heptagon. 8 sides is an octagon. Now, this is not the way that we typically see octagons. Usually, we see it rotated a little bit so that it's flat, horizontal on the top and bottom, and then it looks like a stop sign. That's an octagon. Oct is also the prefix for 8, like an octopus. Nonagon has 9 sides. It's not a ninagon, it's a nonagon. And a decagon has 10 sides. Now, there's a couple other ones that I think are kind of cool names to have just kind of in your brain. 12-sided polygons are called dodecagon. So 2 and 10, dodecagon. And 15, that's the other one that I want you to know, is a pentadecagon. Penta is 5, deca is 10, 5 and 10 is 15. So I'm going to go through this pretty quickly for how we get this formula that we're going to be coming up with. But you can see right now I have a quadrilateral. I have a 4-sided shape. I want to know the interior angles of any polygon based on the number of sides that it has. Now, you should know this one. Just like you know that a triangle had 180 degrees, a quadrilateral could be a square or something else. It has 360 degrees. So this one, before we get started, this polygon is a quadrilateral, and the number of sides, the n, is going to be equal to 4 on this. I want to pick one corner, one vertex, and draw all the triangles that I can from that one vertex. So if I start from this vertex right here, I can't draw to the one that's kind of right above it because that's on the side. So if I draw over to here, that splits it. But again, that's the only other vertex that I can draw to that would give me some space on the inside that's not just a side. So I have 2 triangles. Each triangle, you know, has 180 degrees. So 180 and 180, or 180 times 2, would be 360 degrees. Now, looking at these different shapes, on each of them, I'm going to pick one vertex, draw the number of triangles that I can get. So in letter B, that yellow shape has 5 sides. That's a pentagon. Clearly, it's not a regular pentagon, but I'm going to pick one corner. I'm going to pick this vertex right here. And again, if I draw to that side, that doesn't give me a triangle. It doesn't give me any shape. It's an edge of this already. So let me draw over to here and down to there. And again, if I would draw this one, that's not really a diagonal in the shape. That doesn't do anything. So I've got a triangle here, which is 180 degrees, and then another one here, and then another one here. So I would have 3 times 180 is going to be 540 degrees. In any pentagon, I would get 540 degrees. Letter C, this is a hexagon. I've got 6 sides. If I draw my triangles, I'm going to get 4 triangles, and each triangle, again, has 180 degrees. So I could just do 4 times 180 should be 720 degrees. Letter D, this one has 1, 2, 3, 4, 5, 6, 7 sides, so it's a heptagon. And if I draw my diagonals, this time I get 5 triangles. So 5 times 180, that's going to be 900 degrees. Each time I want you to notice that when I add another side, I'm actually getting one more triangle, right? So I had 2 triangles in my first shape, and then I had 3 triangles, and then I had 4 triangles and 5 triangles. Letter E is going to give me 6 triangles because it's an octagon. But I also want you to know that the number of triangles is 2 less than the number of sides. So when I had a quadrilateral, 4 sides, I had 2 triangles. When I just did this problem, letter D, that was 7 sides, a heptagon, I got 5 triangles. So if I subtract 2, I'll get the number of triangles. So here, because this could get very tedious. If I had a whole bunch of sides, sometimes I'll even give you problems where I don't want to draw out the picture because it's just too many sides. 1, 2, 3, 4, 5, 6 triangles. Each of those triangles has 180 degrees. And again, it was 8 sides to start with. If I would take away 2, that gets me the number of triangles, that's 6. And there's 180 degrees in each triangle. So that's 1080 degrees. Now I'm not going to take the time to write out all of the stuff that we have here, I guess. It does say to go up to a polygon with 12 sides. But remember, if there was a triangle and I didn't even start with a triangle, there'd be one triangle that's 180 degrees. I said I wasn't going to, and now I'm going to. So 4 sides, quadrilateral, 2 triangles, 360. 5 sides, a pentagon. 5 sides had 3 triangles. 3 times 180 is, and I'm just blanking here for a second, that's 540. And then when I had 6 sides, a hexagon, that was 4 triangles. 4 times 180 was 720. 7 sides gave me 5 triangles. 5 times 180 is 900. 8 sides, gave me 6 triangles, and 6 times 180 is 1080. So continuing this pattern without finishing up a table, if I had 12 sides, I would have 10 triangles, the number of sides minus 2, times 180 degrees in each triangle. So if I had 12 sides, I would have 12 minus 2, which is 10, times 180 is going to be 1800 degrees. So we have a rule for this, which is what I just wrote. That capital S stands for the sum of the interior angles, and is however many sides you have. So if I take the number of sides minus 2, that would tell me how many triangles I could get, and there's 180 degrees in each triangle. So here's a pentagon. I know that we just did this with a pentagon, so I'm going to be able to go through this pretty quickly. If there are 5 sides, now this is not a regular pentagon, but it is a 5-sided shape. So 5 minus 2 in parentheses would be 3 times 180 degrees in each triangle. That's 540 degrees. And again, if I pick one vertex, like at the top right here, and I draw to each vertex, I have 3 triangles. I know I didn't draw that perfectly, but there's really 3 triangles, and each triangle has 180 degrees. So the sum of the interior angles for a pentagon is going to be 540. The reading thing that they have right here is if I have a polygon that I don't know the correct name for, I expect you to know the names of 3-sided, so a triangle, all the way up to a decagon, and I would want you to know a dodecagon and a pentadecagon. They even have a 15-sided shape here, and they call it a 15gon, but I'm telling you it's a pentadecagon. If I would give you something that had 23 sides, I don't expect you to look up what a 23-sided shape is called. You would call it a 23gon. The gon is from polygon. That's what all of the different polygons end with. Okay, in number 1, I want to know the sum of all of those angles, and this is a 1, 2, 3, 4, 5, 6, 7-sided shape. 7 is a heptagon, remember? So here is my formula. Typically, I don't even start with this. I usually just do the 7 minus 2 in my head. If there are 7 sides, there are going to be 5 triangles, and each triangle has 180 degrees. This is 900 degrees. In number 2, this is a hexagon, right? 1, 2, 3, 4, 5, 6 sides. So 6 minus 2 times 180. And that's going to be 720 degrees. That means, again, if I would add up all of the angles, all of the interior angles of those polygons. Number 1, hopefully you can do without a formula. This is a quadrilateral. I have 2 triangles. That's going to be 360 degrees. Number 2, we've just done a pentagon twice already. But a pentagon, 5 sides would give me 3 triangles. 3 times 180 is going to be 540 degrees. Now, number 3 is tricky. This is not our typical kind of a problem. So I have to count all these sides, and I'm going to tell you people make mistakes counting on stuff like this because they don't count like this side and this side. They just kind of skip over some of them. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is actually a dodecagon. So if I have 12 sides and I subtract 2, that would tell me how many triangles I could get. And then that'd be 10 times 180 is going to be 1800 degrees. It would be really difficult to try to draw in the triangles here because it's called a concave figure where it kind of pokes in to the shape. So we would have to be really careful with either picking a good spot or thinking about all of the 90 degree and actually 270 degree angles that we have there. In a problem like this, we've got this 7-sided polygon. By the way, 7 sides also means 7 angles. So if you could count up how many angles there are, there's 7, there's also 7 sides. That's a heptagon. So I would start by figuring out the total of all of the angles in a heptagon. So 7 minus 2 is 5. 5 times 180 is, there's 100 or 900 degrees. Now, looking at this picture that I have, I know all of the angles except for one of them. So I could add up all 7 of those angles and say, oh yeah, that equals 900. And then just cleaning that all up, adding together the 6 angles that I know, that would be 778 plus x equals 900. And then you know how to solve this. We would subtract 778 from both sides, and that would leave me with x being 122 degrees for that angle. These kind of problems are all very similar. I don't think that we even need to do all of them. I'm going to do number 5. I want to mention on number 4 that you've got a 90 degree angle in there, so you have to make sure, even though they don't tell you a number, you know that that is 90 degrees to use. In number 5, it's kind of a diamond shape, but it is actually a pentagon. There's 5 angles, there's 5 sides. So if I would start here at this angle, I would have 2x plus 145 plus 145 plus 2x plus 110. Ooh, and I kind of ran out of space, so I guess I'll put my total over here. Now, we've done a pentagon now 3 times, I think, but a pentagon, 5 sides, would be 3 triangles, which would be a total of 540 degrees. Typically, I'd like to have the 540 on the other side, but I kind of ran out of space. So if I add up the 145 and 145 and 110, I would have 400, but I would also have this 2x and this 2x. So I've got, that's weird, 4x plus 400. We can solve this. I can subtract 400. So 140 equals 4x, and then divide by 4. So 140 divided by 4 would give me 35. So if I'm just looking for x, I'm done. If I'm looking for the angles, I would have to go back in and say, oh, 2 times 35, that would be a 70-degree angle, and so would this one. And then I could check it by adding all of those up. This picture, I know, doesn't come through all that well, but this is a regular polygon. This is actually a cloud system on Saturn, and it happens to be a regular hexagon. Now again, regular means all of the angles match and all of the sides match. And that hexagon that's in the center, I kept this problem in here because I thought this was crazy. This hexagon is about 15,000 miles across. You could fit 4 Earths side by side across that. That's huge, and that's just one big cloud system. Anyway, once I know that, because I know that it's a regular hexagon, we can do this math and figure out, oh yeah, that's right, there's 720 degrees in a hexagon. Because all of the angles are exactly the same, I could take that 720 and divide it by the number of angles, which is 6, and I would get that each angle is actually 120 degrees. So these are our last ones. These are regular polygons. Number 6, it's getting close to being a circle almost because there's so many sides. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's a dodecagon. 12 sides. Minus 2 would tell me how many triangles times 180. That's the sum of all the angles. So this is 10 times 180 is going to be 1,800 degrees for my dodecagon. And I've got 12 equal angles. So I would take my 1,800 and divide it by 12, which gives me that each angle is 150 degrees. And again, the reason this is getting close to being a circle, think about how big those angles are. 180 is a straight line. So we're getting angles that are looking bigger and closer to just kind of turning into a curve for a circle. For number 7, this last one, we've got 1, 2, 3, 4, 5, 6, 7, 8 sides. This is an octagon. 8 sides would be 6 triangles. So I would have 6 times 180. I'm going to show you kind of how I would write this out personally. 6 times 180 would give me the total of all of the degrees, but I'd have to divide it by 8 angles. This is how I'd find one angle. So I'm going to have 6 times 180 is going to be 1080, and then divide that by 8, which would give me 135 degrees for one of those angles. Today, your practice problems are worksheet 3.3b. When you're doing that, make sure that you're reading very carefully to know that you're finding the right information on each problem. The answer key is in Schoology, so if you get stuck on anything, make sure that you check that out, and then make sure that you take the learning check. If you need any help, let me know.